This video is for Chapter 3, Section 3.3 for the activity set where we're going to multiply with base 10 pieces. So we're going to model whole number multiplication ideas and we'll use a flat, a long, and unit pieces. So when we think about multiplication, we often think about it as repeated addition. For example, if we're looking at 4 times 8, we can think of this as 4 copies of 8, or 8 plus 8 plus 8 plus 8. And if we're illustrating this repeated addition with 8 tiles, or units, either way to think about it, then you can think of it as 4 groups of 8, and you can push it together to make a rectangle that's 4 by 8. So you can call it a rectangle or a rectangular array, whatever works for you. So one possibility when we're thinking about our model for multiplication is a rectangle, and the two factors are the dimensions of the rectangle. So 4 times 8 makes a 4 by 8 rectangle. And this helps us think about multiplication and connect to our multiplication algorithms. In question 1, we look at the product 7 times 12, and we can do that same thing. We can make 7 copies of 12 and push it together to make a rectangle. So you can see our rectangle has dimensions 7 by 12 here, and we have 7 longs, but we have 14 units. So we would want to get the minimal collection and carry and convert those 14 units to 1 long and 4 units to see our final solution of 84. In question 1, we ask you to continue this idea and make the rectangle for 7 by 23. So in that same way, we set up 23, and then you'll want to duplicate and make, or use your pieces and make 7 copies. And again, you might want to make a minimal collection. It will change your shape so it's no longer necessarily a rectangle when you make your minimal collection, but your original 7 by 23 dimensions will get you started. In question 2, we look at 2-digit by 2-digit multiplication. So here we have 12 by 13. So again, we have a rectangle measured 12 by 13. And notice here now when we do our minimal collection, we get a sort of nicer rectangular shape. So I have my 12 by 13 rectangle set up, and when I join my pieces, I start getting some interesting things. Sometimes this is a little messy and you have to clean it up. So let's see. So I can do that, and I can get my 12 by 13. In this case, I really have to do a little extra work to get it to line up. And once I have it lined up, you can see that I have 12 on this dimension and 13 on this dimension still. For number 2, we ask you to continue with this idea and make some rectangles with your base 10 pieces. And in each case, figure out the final product. Then in number 3, we connect this to the way that we usually multiply. That's the traditional or standard paper and pencil algorithm. So for example, we have 23 times 24 here. So we have 3 times 4, 12, 3 times 20, 60, 2, which is really 20, times 4, 80, and 20 times 20, 400. Then we add them all up. These are called partial products. These are the 4 partial products of the traditional or standard paper and pencil algorithm. And you really want to be able to match these to the model that you make. So for example, we have our 12 by 13 model here, and we have this marked in our activity set. And you can see it here as well. If I think of it as 10 by 10 here, and 2 by 10, and 3 by 10, and then 2 by 3, then I can see how my partial products align. This is my 10 by 10, this is my 10 by 3, this is my 2 by 3, and this is my 2 by 10. And this matches our traditional paper and pencil standard algorithm. So in number 4, we ask you to continue doing this, and we point out that you can make a simpler sketch of this. And then we ask you to just do this for a couple of problems. So draw the base 10 sketch, and you can do a simple one like this, and then find the product, and then relate those partial products to the regions of the model, like we've done here. I hope you have fun with Activity Set 3.3. It's really useful to understand how the partial products and the model match. It really helps you help kids understand how that multiplication algorithm works.